Okay, as I said, my Zoom on my computer is not working. It keeps crashing when I open it. So I decided to make a video of the presentation just so you guys can get the information and you don't fall behind. So the warm up was give a reason for each statement. So this is kind of focusing on what we talked about last week, justifying our mathematical statements with reasons. So here, if, and this is the condition, angle 1 is equal to 90 degrees and angle 2 is also equal to 90 degrees, then you can make the conclusion that angle 1 is equal to angle 2 because they're both equal to 90 degrees. This would be the transitive property of equality. Okay. The second one, if segment FG is congruent to RS, then FG is equal to RS. This is the definition of congruence. So if two quantities are congruent to each other, then they must be equal in measure. This is the definition of congruence. Okay. So if I wanted to arrange these statements in a T-chart with my statements and reasons, then it would look something like this. My first statement would be my condition here. So let's say the measure of angle 1 is 90 and the measure of angle 2 is also 90. And let's say my reason for this is given. That's just something that I already know. The fact that they're both 90 degrees isn't coming from anything else. So because they're both equal to 90, then I can say angle 1 is equal, the measure of angle 1 is equal to the measure of angle 2 because of the transitive property. Okay, so the if-then statement, when you're organizing it into the T-chart, the if part, the condition is one statement, and then the conclusion is the second statement. Okay, the same thing, I can keep going and write if FG is congruent to RS, and this is actually just given. That's something that's given by the statement. Then you can say FG, the fourth statement would be that they're congruent. And the reason would be the definition of congruence. Okay, so the statements as a sentence, if you want to organize them in a T-chart, you kind of have to break them up into two separate statements. And because every statement needs a reason. So the if part, the condition, well, why is this actually even true? Because it's given to us. Sometimes the condition can be, the reason can be the segment addition postulate. Because postulates don't need any additional information. They just exist. They're true because of their existence. So this is just an example of how you can organize it on a T-chart. And we're going to look at various ways to organize a proof. Okay. All right, the first example of our proof here, here's the diagram. You're almost always going to be given a diagram, or you're going to be given some information. So in the diagram, the measure of angle ABD is equal to the measure of angle CBE. So you can mark that on the diagram. ABD goes from points A, B, and it's the angle in between A, B, and D. So here's ABD, is equal to angle CBE. CBE is going to be from point CB all the way to E. So that is actually this entire angle in pink. So first of all, you should notice that these two angles actually overlap. They share angle 2. Okay, so you're has to show that angle 1 is congruent to or equal to angle 3. So I'm actually going to put that right here because, again, that is the end of my proof. That is what I want to show as I write my proof. That's where I want to end up. Remember, the blanks here are my reasons. The ones in the boxes are actually my mathematical statements. Okay, and I'm actually going to type this. So I'm going to move stuff around. So the measure of angle 1 is equal to the measure of angle 3. So that's where I want to end up. And I know I'm always going to start with my given information. So the measure of ABD is equal to the measure of CBE. And my reason for that is going to be given. That information was given to me by the problem. Now, looking at let me go back and actually all right, so these are the two angles that are congruent, ABD and CBE. So that is given to you. So from here, well, we have angles, and if you notice, ABD is actually in the picture, it's made up of 1 and 2. So there is a postulate that we can use here to rewrite. So we can rewrite ABD as equal to angle 1 plus angle 2. And this is actually the angle addition postulate. Would be my reason. And I can do the same thing here with CBE is equal to angle 2 plus angle 3. Same reason. You can use the same reason. Angle addition postulate. Okay. And now I can, if you look at both of these statements here, I'm given that they're both equal to each other. So then I can actually conclude that since ABD and CBE are equal to each other, I can do something like this. Angle 1 plus angle 2 is equal to angle 2 plus angle 3. All right. And there's an extra step. You could have actually substituted CBE here and then use the transitive property. But here we can actually just directly go to the transitive property because ABD and CBE are equal. So because 1 and 2 and 2 and 3 are both equal to the same thing, those two angles, you can actually say they're equal to each other. And it would be the transitive property of equality. Okay. Now, if you look at this equation, you have angle 2 on both sides. You're very close to what you need to prove. So if you can find a way to get rid of angle 2 on both sides, you have arrived at what you need to prove. And that would actually, you can actually subtract angle 2 from both sides, and that will give you angle 1 is equal to angle 3. So this is a subtraction property of equality that supports this. Okay. Now, this is actually in a flow chart, but I can actually arrange this into a T-chart. Okay. So because all of my statements are in yellow, my reasons are the ones in black. So if I was to rearrange this, I can put my statement, start with my first statement. I would need to definitely number these. So my first statement is here, and it's given to me. Okay, now my second statement, my second reason. The third statement, okay, and my third reason. My fourth statement, oops, this is my, and my third reason is the same. Right? And then finally, my fourth statement and my fourth reason. Okay, so always start with the given, and then you need to then look at like the reasons that you know that you can use. Usually, if you start with the given and there's nothing else that you can get from the given, for example, if I told you something was the midpoint, then you can say this segment is congruent to this. But I can't really do anything with this given in this problem. So then I'm going to go to a postulate that I know exists that I can use based on what the problem deals with. I use angle addition because we're dealing with angles. So again, this is the same proof, but I've now organized it as a T-chart. And the way you would read this is if you were to do an if-then statement, this would be the if. If these two angles are congruent to each other, then I can make this statement. I don't need them to be congruent. I can make this statement, angle addition postulate exists even if these two angles, even if ABD and CBD are not congruent to each other. But this is just an example of how you would read the T-chart, because the if-then statements are broken up into two separate statements. Okay. 2 and 3 together make up 4. So if ABD is equal to angle 1 plus angle 2, CBE is equal to angle 2 plus angle 3, and ABD is equal to CBE, then I can make the transitive property. So when you organize it in a T-chart, these statements build on each other. Every statement depends on the statement before it, or uses the statement before it as a justification. Okay? All right, that was the first example. Oops. Okay. Now, the second example here, we've done this example before. We did this last class, but the goal of this is I want you to see how the flow chart kind of relates to the T-chart here. And again, here are the reasons, and usually with proofs, you're going to have to just pick the correct reasons for the statements. So in this diagram, AB is equal to CD. So again, that's what I'm starting with, given. Now, from there, I know I want to end up with showing that AC is equal to BD. That's what I want to show. And just looking at this picture, I know AC is made up of two segments here. So I can write AC as AB plus BC, and BD as BC plus CD. Yeah. Segment addition postulate. Okay. All right, segment addition postulate. I can use it twice to write these statements, and I know AB is equal to CD. So I'm going to actually substitute here and say AC is equal to CD plus BC, and I'm not going to change the second statement. BD is equal to BC plus CD, all right? So by substituting, this is a substitution property. It's substitution property because all I did was replace AB with CD in my first equation. I didn't change anything else. So substitution property. And now AC and BD are both equal to the same thing. So then I can say transitive. Because of the transitive property, these two segments must be equal. Okay. I'm not going to rearrange this into the T-chart, but you can. Your statements are in purple. You have to number them. You start with the given, and then it doesn't matter which segment addition postulate, which statement you put next, and then you would substitute, and then the transitive property is last. So if you were to organize this in a T-chart, you just need to number your statements and reasons. Okay? All right. Last example here. These proofs are kind of the same. They're kind of the same type, but some deal with angles, some deal with segments. So here you're designing a logo to sell daffodils. Use the information given. Determine whether EBA is congruent to DBC. So that is what you're trying to show. So I'm going to go ahead and put EBA is equal to angle DBC. That is what I want to prove. Now I'm going to start with my given here. My given in this example is actually in the diagram. I'm given that angle 1 is equal to angle 3. That is given. Now, so from there, okay, I'm dealing with angles, and EBA, if I look at EBA in my diagram, EBA is made up of angle 2 and angle 3. So I know I can use the segment addition postulate here. So I'm going to say EBA is actually equal to angle 2 plus angle 3. Angle addition postulate. Same thing here, angle addition postulate. And I can say DBC is equal to angle 1 plus angle 2. So I can say angle addition postulate there too. Now, angle 1 is equal to angle 3. So I'm going to substitute into one of my equations. So instead of angle 3, I'm going to put angle 1. And I'm not going to change my second equation. So again, I use substitution here. So now, because of the transitive property, I can say EBA is equal to DBC because the right-hand side, they're both equal to angle 1 and 2 together. And in the diagram, you'll see angle 2 is what they have in common. This should say angle addition. But yes, so these are the reasons that you would use, okay? In this one, I wanted you guys to log into Nearpod, but obviously we can't do that. We will try Nearpod next class. So 4 steps, here's an example of also on the quiz, I might ask you something like this, like come up with the reasons. You'll usually have the option here you'll have the option to pick your reasons. So looking at this, you're given that AC is equal to AB plus AB. And you're asked to prove that AB is equal to BC. So in a way, you're kind of being asked to prove that B is the midpoint here. So if you can show AB is equal to BC, then you can conclude that B must be in the middle. So you always start with the given. The given information is AC is equal to AB plus AB. That's given. Now, this has to do with segments. So again, I should be thinking about the segment addition postulate. So segment addition postulate is my second statement. And notice it doesn't really rely on the first statement. So the given doesn't really contribute to the segment addition postulate. And that is true for postulates. They're standalone statements that don't need a condition. As long as you have these 3 points are on a line, this postulate will be true. So AB plus BC is equal to AC. So now, using statements 1 and 2 together, you're coming up with 3. So statement 3, as you can see, is AB plus AB is equal to AB plus BC. Okay, and that, if you examine statements 1 and 2, they're both equal to AC. So this is actually the transitive property. Okay. And to get rid of that AB on both sides, so if this is true, then you can say statement 4, AB is equal to BC. You're getting rid of AB on both sides by using inverse operations. So subtract AB from both sides to get AB is equal to BC, and this is the subtraction property of equality. Okay. All right. So that was the one I wanted you to do. Can't do the time to climb. We can do one last proof here. And we will do the statement and reasons here. So we're going to do this one completely from scratch. So, statements, reasons. So you're given that M is the midpoint of AB. Okay, so normally if things aren't marked in the diagram, you should. So if M is in the middle of AB, I can say AM is equal to MB. That's a conclusion I can show by doing these tick marks. I'm asked to prove 2 separate things here. Okay, but my first statement is always going to be what's given. So what's given is literally has to be the words that are given to you. You can't say AM is equal to MB. That's not given yet. That's something you concluded based on the given. So the given is M is the midpoint of AB. Given. Now, if M is the midpoint of AB, then you can make that second statement. Well, what can you get from that information? You can get this piece of information, this statement, AM is equal to MB. But what is the reason for that? Well, that is the definition of midpoint. Okay. So again, you read it as if the first statement, which is the condition, then the second statement, the conclusion. And the support for that is definition of midpoint. Okay. So now there's nothing else I can get from the given. So my third statement I'm going to think back to my reasons here. Well, I know these are AB is the entire segment, and I can always use the segment addition postulate. I can say AB is equal to AM plus MB. Segment addition postulate. Now, looking at statements 2 and 3, I can do some substitution here. I'm going to replace AM with MB. Whoops, I'm actually not going to do that. It actually helps to replace MB because look at what we're trying to prove. We want 2 times AM. So we actually want AM here. So I'm going to replace MB with AM. Substitution. You just added combined like terms here, so this would just be simplified. Okay, so here you go. You proved that AB is equal to 2 times AM. Now, you can also show B very easily by manipulating the same equation here. Now, you, instead of showing AB is 2 times AM, you can divide both sides by 2, okay? And you'll get 1/2 times AB is equal to AM, right? Because AB divided by 2 is the same as 1/2 times AB, right? And this is the division property of equality. And then finally, this is kind of nitpicky, but it does matter. If you look at what I'm trying to prove, the statement B, I started with AM here. But in my actual proof, I'm starting with 1/2 AB. We know these two equations are the same thing, but I'm going to have an extra statement here and say, actually, I'm going to write it the way they asked me to, right? So the last statement. And my reason for this, and some of you can already see that what did I do from 6 and 7? I just switched things around. So this would be the symmetric property of equality. Okay, so hopefully this is helpful for you, enough for you to do the checkpoint. We're going to do more of these on Thursday. And actually you'll have more opportunities to do this tomorrow on your own. Okay. Now the last thing in this lesson that I wanted to go over was some theorems that are coming up. And these, again, can be used as reasons. So these theorems, remember, have to be proven. So right angle congruence theorem says all right angles are congruent. This seems kind of obvious because all right angles are 90 degrees. Now, the proof for that, so this is the proof for it, because remember, theorems need to be proven. They cannot just be, they're not true just because of their existence, like postulates. So this theorem, the proof for this theorem is here. You don't have to write the proof out every time you're trying to use the theorem, but it's helpful to know the proof. So you're given that 1 and 2 are right angles. I start with my given information. Now, the definition of right angle, and you'll see this, I'm about to post a document with all the reasons that you could use. And this is one of the reasons. The definition of right angle says if two angles are right angles, then they must equal 90 degrees. So you're given, so if angle 1 and 2 are right angles, then I can conclude that angle 1 is equal to 90 and angle 2 is equal to 90. That is the definition of right angle. Okay. Now, if angle 1 is equal to 90 and angle 2 is equal to 90, then angle 1 and 2 are equal to each other. You see, it's a transitive property because 1 and 2 are both equal to 90 degrees, so they must be equal to each other. The transitive property of equality. And then going from statements 3 and 4, if angle 1 is equal to angle 2, then they must be congruent to each other. That is the definition of congruency or congruent angles. So this proof shows you that, hey, if two angles are right angles, then they must be congruent. The next one, the congruent supplement theorem. I'm actually going to save this for Thursday. I think this is just easier to do when we are together. But actually, you know what? Since I have it here, I'll just give you a quick overview of this. So congruent supplement theorem, which again, you're going to get a list of reasons that have to do with angles next time. So if two angles are supplementary to the same angle, then they are congruent. So if 1 and 2 are supplementary and 3 and 2 are supplementary, then angle 1 is congruent to angle 3. So 1 and 2, so 1 and 3